Everybody. So today we are going to cover some probability type stuff. I think one of the very cool things about probability that I like to do with students is this idea that um, probability and combinations are incredibly closely aligned. And that's kind of what I want to cover today. We do a really good job of it in our course. And I want to go through some of those questions. Now, hopefully, for those who've been through combinations and probability, this is a pretty basic concept to you. Because initially, it's something that I don't think most of us know, even though those who took probability classes, statistic classes, you really, it wasn't until I started dealing with the GMAT till I was able to see, um, how closely aligned those things are. So, yeah, so that's what I want to work on today. We'll do about 30 minutes of questions, and then we'll wrap up, do a little bit of Q&A, and go from there. So, just getting the appropriate document open. Then here we go. Okay. Let's see here. One sec as this opens. Okay. So for some of you, if you haven't touched this might be new to you, but it's okay. Just follow along the best you can. And, eventually, assuming you are using TTP, you will get to this. But, once this stuff clicks, it's really nice. So take a look at this one. To start, I'll give everyone about 2 minutes, then we can chat. All right, let's talk about this. Did anybody notice how combinations could play a role in a question like this, first and foremost? You can put your answers in the chat box if you agree. Okay. Yeah. Now, can this be done another way? It can, but I am firmly entrenched in the idea that doing this using combinations is the best move. So you've got your favorable outcomes. What needs to happen with the favorable outcomes? Well, you need 3 cats and 2 dogs. So that's 5 choose 3 times 3 choose 1. Now, that in itself is a combination question, because if this problem said, how many ways can you choose 3 cats and 1 dog, excuse me, and 2 dogs, sorry, so that would be 3 choose 2, that would be a combination question. Exactly, it's the same thing. And then the only difference is you're doing the total outcomes here, so there's 8 total animals, 5 are being selected, so now you just do it out. So 5 times 4 times 3 over 3 times 2, that becomes 10. 3 choose 2 is just 3. 8 choose 5, 8 times 7 times 6 times 5 times 4 divided by 5 times 4 times 3 times 2. The 5 and the 4 go away. 3 and the 2 go away with the 6. So it's 30 over 56, which ends up being, of course, oops, hold on, 30 over 56, which is 15 over 28. So yeah, it's a really cool thing once you realize, what's kind of being tested there and then that efficient way of dealing with it. So let me give you another one. Take this here. All right, same deal, everybody, right? So 4 even numbered cards, 7 odd numbered cards, 2 even, 2 odd. So we're talking about 4 choose 2 times 7 choose 2 over 11 choose 4. And if you do that out, I mean, everybody got E, so I think you guys are good there. So I think everybody has some insight into this process. It ends up equaling 21 over 55 after everything is reduced. So that's a great way to deal with these. Now, what I want to show you next is how, as combination questions get a little twisted around, so too can the probability questions on which those are based. Now, you're going to remember certain types. So like, for example, this is, I would call this a less straightforward problem, but still in the same, realm of what we're talking about here. So take a look at this. All right, so let's talk about this one here. So we've got 9 chips, 4 red, 3 black, 2 white, 4 selected, none of the black chips. So as you would do with a combination question, right? You remove the black chips from the running of being selected, right? So originally we were going to select 9 chips, or there were 9 to select from, but the thing is, if the black ones aren't included, that drops the number that we have down to 6. We still need to get 4 total chips, so that's 6 choose 4. To do the total outcomes, we take the total number of chips and the total number we need. That's 9 choose 4. So if we do that out, 6 times 5 times 4 times 3 over 4 times 3 times 2. We get some canceling here. That's going to be 15. And then 9 choose 4, 9 times 8 times 7 times 6 over 4 times 3 times 2. The 8 here, 4 goes into that 2 times. So we end up with 15 on the top, and then a 9 times 2 times 7. Now, if you don't want to do 9 times 2 times 7 out initially, what you can end up doing, of course, is reducing here. 3 goes into this 5 times. 3 goes into this 3 times. Now we're dealing with a much easier number. That just becomes 6 times 7. 5 by 42 is our answer. So hopefully, it looks like most of you guys are getting this correct. So it's pretty straightforward for you, which is good. Now I can show you before we, stop doing questions here today, what, probability with multiple outcomes looks like where we're not using combinations, just to juxtapose the two. But first I want to do one more here. So take a look at this. right, so hopefully you guys are doing the same thing here. What's the probability that Roberto is selected, but Jose is not? Well, that means that they are accounted for, right? So instead of there being 9 snowboarders in the favorable outcomes, we're talking about 7 snowboarders, right? And Jose is not selected. Roberto is selected. So there's 3 people left to now be selected. The total outcomes, of course, or the total number of people is still 9. And then we need 4. So that's without any restrictions. So we do 7 times 6 times 5 over 3 factorial. That's going to give you 35. 9C4, that's going to give you 9 times 8 times 7 times 6 over 4 factorial. That's 4 times 3 times 2. And then we're going to do some canceling. So we end up with 9 times, so basically 35 over 9 times 2 times 7. Same deal as before. You can do some canceling out here. 35 is basically 5 times 7, of course, so the 7s cancel, and we're left with 5 over 18. What I want to do is I want to show you probability. The last question we'll do is just probability with multiple outcomes. We'll do one of them so you guys can see the difference, and then we can do some Q&A. Let's find the right question. Here we go. Okay. Take a look at this here. Yeah, work on this guide. Okay, so in this one, you can't use combinations, right? So when we have the coin being flipped 4 times, we have exactly 2 heads, right? So what we're doing is heads heads, tails, tails. Now, it's 1/2 for each of them, so that's 1/2 to the 4th power. It's going to give you 1/16. But the thing is, we care about how many ways we can arrange HHTT. So that gives us 2 factorial. There's 4 total letters, so it becomes dividing out the repeats, 4 factorial over 2 factorial times 2 factorial. So 4 times 3 times 2 over 2 times 2, that's going to give us 6. So then what we do is we multiply 1/16 by 6, 6/16 gives us 3/8, and that's our final answer. So that's the difference here, is that in this case, because each flip has the same probability, you have to just do it out the straight way and then figure out the different ways to arrange those numbers. All right, so that's it. I think we covered a decent amount of ground today. Does anyone have any questions about their prep, anything in general, anything you want answered here? These webinars are about once a week, depending on the week. Balancing speed and accuracy, I think you just focus on accuracy first, and then eventually speed comes because it comes from being able to recognize what's being asked and then quickly execute. So that just takes time, you know what I mean? So you'll get there, but if you can get accurate, you'll be in a great spot. Yeah, we can go back to the other question. Any other questions here? Yeah, when you're doing practice tests, you just got to keep practicing them. Eventually, you'll get better with them. No, don't use the formula guide when taking the chapter tests. And just give me 1 second, everybody. All right. TTP can be enough. A lot of the times, that's all students use. If you want extra practice, yes, you could use the official guide. You don't need more than that. Oh, the question before that. Okay. All right, cool. Well, that's everything, everybody. Thank you for coming. I think we'll be doing a webinar next week. Yeah, about 500 hours is about right. I think we'll be doing a webinar next week, but if not, have a happy holiday. But thanks for coming, and reach out if you need us, okay? So keep studying hard, and we'll all talk soon.